Anyways, we're going to talk a little bit today about intelligence risk-based adaptive authorization, right? So everybody's familiar with adaptive authentication. You know, there's probably 70 or 80 vendors in the marketplace that are doing some form of adaptive authentication, which is fantastic. You know, it's that front door. You know, the next question is what do I do from an authorization perspective? How do I make real-time risk-based decisions within my applications, within my microservices, within my legacy apps to try and mitigate risk as defined and as I see it coming from my data security devices, behavioral anomalies, et cetera. And that's going to be kind of the crux of what we're talking about. So first of all, you know, why is it important, right? The breaches continue. They becoming more and more frequent. They're becoming more and more expensive, even though the actual numbers of data loss are becoming smaller. You know, so how do we protect against, you know, this fence, right? This perimeter fence that we've built that, you know, every dog, every horse, every kangaroo seems to be get over in some way. And I think first, I'm so sorry. I think first it's important to talk about what the problems are, right? What's causing this change in authorization, right? So first of all, there's a cloud shift. There's a completely different method of building applications as well as seeing what's going on within those applications. Going from your perimeter-based 3-tier applications into applications that might be running in Istio, Kubernetes, Dockerized containers, et cetera, that have ins and outs on every side as opposed to being protected behind that common ingress-egress point, you know, your firewall, your WAF, your typical web access management gateway. Secondly, there's traffic model shifts that are making things increasingly complicated, meaning instead of going down that typical transaction where I go have a user talking to a web app, talking to a business function, or to the business logic, talking to the data store, which, by the way, was very, very complicated even just to try and audit a single user going from authentication all the way and trace them all the way down to database query. Now I've got a myriad of microservices. I've got very complex cascading multi-step transactions that are API or REST or gRPC based, and I've got to be able to figure out where things break or where the breach happened or where the data leak came from. Thirdly, you know, there's a massive application architecture shift, right? And this is kind of feeding the first two, where we've gone from that 3-tier app into kind of these distributed microservices, and whether it's serverless functions or whether it's containerized microservices, the model's changed entirely, meaning I am pushing all of my functions and replicating them and distributing them across multi-clouds. As part of that, we have that shift in distributed security, right? Going from, again, the perimeter-based app to needing something that's much more app perimeter specific. Finally, we're seeing a data model shift, right? IAM has traditionally been, you know, an LDAP directory as the data store that is very regimented from a user-centric idealism. So I've got a user using 2 or 3 devices across, you know, a handful of applications. It's kind of been the model. But instead, now I've got shared devices. I've got consent I'm passing back and forth. I've got a very flat data structure that just doesn't lend itself to building relationships well in the way that LDAP was designed for. I mean, LDAP was written in 1993. It's not really what I would call the advent of cloud. So as part of this, this all bubbles up into an authorization shift, right? So on the left-hand side, we kind of have what authorization looks like today. You know, we've got complex static policies, we've got centralized policy management, centralized policy decision point, a few distributed policy enforcement points, but very static web gateways that are doing most of the offloading of authorization for the underlying applications. If the underlying applications want to use things like fine-grained entitlements, permission consent, they're having to do external API calls to actually do that and bring that data back, which is expensive. It slows down the entire application itself. And then even more so, it's not necessarily unified across all of your application base. On the new side, we actually have adaptive distributed decisions. And so what that means is I have these flexible decisions that have to be much, much simpler. If you think about where firewalls were in 1999, it's where I think about identity being today, right? So we went from having like 15 firewall rules, very static, very regimented. I can get to this section of a subnet, you know, I can get to FTP on this subnet, and then all of a sudden, by 2003, 2004, I had 5 different products and 15 million firewall rules. It became completely untenable, completely unmanageable. Static policies of that nature play into that exact same role, where I've got, you know, very static, regimented, you know, OAuth scopes, very static, regimented access policies, and they're not flexible enough, and they're too fine-grained to really manage at massive scale when I start thinking about IoT and pushing my perimeter down to, you know, my Tesla, or pushing my perimeter even down to my mobile device. So we need all of these net new features that are all wrapped up in an approach that Gartner likes to call CARTA, which is Continuous Adaptive Risk Trust Assessment. And they have a distributed policy enforcement point, distributed policy decision point, distributed policy provisioning that's automated as part of your CI/CD processing, delegated policy provisioning. So I want my CIO to set the policies. I want my BUs to inherit those policies. I want my applications to inherit subsets of those policies, and my developers to adhere to them. And we'll talk a little bit more about that when we get into the CI/CD pipeline. I also need to have data service agnostic policy enforcement points. So if you remember back like the first wave of IAM, 2004, 2005, everybody had all of these agents that would run in your app server, right? And then you had to upgrade the agents, and they were tough to manage centrally, all that other stuff, because every agent was specifically designed for every style of app server, even every version of Java. So we've got to avoid that. We actually need to make sure that the agents or the enforcement and decision points are completely agnostic of the underlying OS. So you can have a singular agent that protects Perl, that protects Java, that protects Go, and any other polyglot environment. Finally, make sure you're having cloud-based scale and distribution. You know, we're literally talking about having, what, 50 billion IoT devices, I think was Cisco's last release by 2021 or 2022. So to push those policies out that far and try to manage that type of scale of policies, even across hundreds of organizations, is almost impossible to comprehend the complexity there. So if I don't simplify those policies, make them much more intelligent, much more dynamic, I'm going to run into all kinds of management issues. So make sure to keep them lightweight, very fluid. So this would be like our end goal. You know, if we could just, start from scratch and say, hey, I want a miracle. I want to take, all of my behavioral intelligence. I want to take all of my data security intelligence. I want to take any additional external threat intelligence. I want to process it. I want to create a risk score, right? And that risk score can be applicable everywhere. Maybe on the left-hand side, I actually want to set up my policies that are dependent on risk, right? And I want to move to, let's call it a non-binary authorization policy, right? So instead of just yes or no, what about if in the middle I have a gray mush area? And that gray mush area is mitigation. So when I start to think about how can I improve customer experience, I never want to block a customer. I mean, everybody in here has had a BU that said, no way, we're not going to block that. So how can I actually do something to increase trust right in the middle of the transaction? How can I use that gray mushy area to actually improve the user experience? Add the friction when it's needed, leave it out when it's not. And then when things happen in a transaction, high value transaction, a new threat emerges, you know what, that risk score bumps up. And then all of a sudden, I insert something in the middle of the transaction. I say, you know what, let's prompt for MFA, but not session step-up MFA. Let's actually insert transaction-based MFA. Let's turn up auditing, send it off to the SOC. Let's tell you to go out and patch your endpoint. You're running Android 6, you know what, I want you to run Android 8 or above. Or insert any discrete business process. And this is where things actually really start to get interesting, because if we all look at this and say, you know what, holistically, Nate, I agree with you. Actually, Nathanael, whatever. I agree with you. So now the question is, how do we get from here to there? And so we have an itemized list of how to get there, right? So first of all, manage all the entities. Let's rethink what entity means, or even identity means. Second of all, let's plan for our next generation of access control. There's a couple of different net new standards that NIST is pushing, UMA's coming out, et cetera, that are designed to really enhance what can be done at the access control layer. Make sure we have distributed policy, decision policy, enforcement points. When I start to think about my developers building all of these distributed applications, I need to marry those with identity microservices. I can't say, you know what, I'm going to go call a cloud IDAS for every authorization, right? I just killed my performance. Or I want to go and call my monolithic stack that's sitting on-prem somewhere. You just killed all of your performance advantages of having a distributed application. So I need to marry things and give my developers the tools to have those distributed policy decision, distributed policy enforcement points to make these complex decisions in real time when the transactions are hitting those microservices. Next up, unify and centralize policy management. When you start to think about what that means, like where are my policies stored, right? So again, go back to like a web access management or a traditional data center style model. I've got policies at my firewall. Can I get into this subnet? I've got policies at my load balancer. Can I get to this VIP? I've got policies at my actual application where I'm saying, or my web access management gateway, where I say, what is at my OAuth scope? Can I get to this URI, section of the URI? I've got policies within my applications that are saying, what are my fine-grained entitlements? What are my permissions and consent for this application? So I've got all these different things stored in different areas that never talk to each other. I don't have a way of presenting back to my management or back to my CISO. Well, here's your threat modeling based upon your authorization policy. Or here's what your applications look like from an authorization perspective. Finally, we've got to integrate with DecSevOps. Let's push this back into the developer value chain. We'll talk a little bit more about how that happens. And then keep a stateless orchestration, right? So everybody's got a multitude of identity products, right? And there's a fantastic way of being able to pull those together with the advent of microservices and being able to, instead of just looking at it as, hey, I've got Oracle, hey, I've got IBM, I've got Ping, I've got ForgeRock, whatever it may be, start to be able to marry those together, not just from a data version, but make sure they're all intercommunicating properly so your business units are reconsuming the same types of tokens, mapping relationships between what's stored in all of those what's stored in all of those individual identity silos across your business. So let's start with the identities in a transaction, right? And I purposely put services right at the top of this instead of the user right at the top, because I think we, as the Identirati, as we like to name ourselves, need to reconsider how we think about identity. It's not user-specific anymore. The user side is, I don't want to say it's solved, but it's pretty well understood, and there's a lot of solutions to meet user needs. If we think about the services side, in this case we're talking about microservices, your existing monolithic apps or legacy apps, APIs, etc. Those are actually what are making the data queries on a user behalf. So my question starts to become like, well, how can I ensure that the right data, because now I'm distributing these everywhere, the right data gets to the right service even before I authorize the user into that service? Like, let's flip that model on its head a little bit. Let's create everything, or let's track and give identity to everything. In a lot of ways, dumb things are essentially like services right now. They're just data publishing services that go to an IoT-style hub. But they're getting more and more intelligent, where we'll have bidirectional communication, even to the sensor on my gas tank on my Caterpillar tractor. And then finally, users, right? Even though it's well understood, let's reuse what's already been built, right? If I'm already have a fantastic IDP, let's continue to use that and embrace and extend that into the multi-cloud, hybrid cloud environments. So create all those as a first-class citizen and be able to build relationships off each one of those. So if we think about net new transactional models, I've got transactions where a user will never be involved, right? You have that today. It used to be called like batch processing, right? But now I've got other partner services calling my services. I've got things talking to services. It might be on behalf of a user, it might not, but I need to track that requester all the way through my microservices and other services that it's consuming. Let's build orchestrated interactions, right? And this is the beauty of breaking things apart into microservices. I can insert business logic at any tier. I can take an incoming SAML transaction, perform the SAML assertion, thumbs up. But before I create a session, I want to insert a discrete business process. So let's take advantage of that. Let's move that beyond kind of just the conceptual and be able to aid our business owners by giving them the technologies and the flexibility to create all these next generation mind-blowing applications that they've been considering. And then we've got to embrace microservices from an identity perspective. A lot of people hold them at arm's length or don't really understand them. I was pleased to see there was, 3 different tracks yesterday on just microservices. It was fantastic because it's kind of the turning point. Hopefully it's the culmination of years of work. But we've got to be able to work with the developers, work with these net new apps, because so far, as we look at IAG, and I'm not saying it's unimportant, but it's kind of looking backwards, right? Because we're saying, okay, we need to protect these legacy apps, but at the same time, my BUs, my developers, are building all these net new features, functionalities, and they're not abiding by, the identity protocols maybe that I gave them already. So I need to figure out ways to engage with those developers to make sure we're protecting the future. Otherwise, we're going to keep on, walking backwards into the past. So what could this look like, right? And this is a model for that risk-based authorization engine, where you can take external risk modifiers, right? Again, taking that threat intelligence, maybe your internal fraud engine, grabbing your data security infrastructure. The IDSA is doing a tremendous job at bringing this forward, and start to say, hey, I'm gonna consume the data from my WAF. I'm gonna consume the data from my endpoint protection. In addition, let's use internal risk modifiers for what we're seeing, because now we're auditing, again, end-to-end transactions from user authentication all the way down to the data store query made on their behalf. So I've got a much richer data set to perform delegated rules engines and machine learning on, so I can track user interactions much, much better. Let's also build in attack analytics. What's happening in the apps themselves? Is there a RAS present on that app? Is it publishing data back? How can I consume all that in real time using what's happening on the wire so to make these much more complex authorization decisions, but I've got to keep the authorization policies simple. Next up is the engine, right? So an engine that's actually consuming all this data and then also providing a way to do policy management and usage of that data. This is where your dynamic rules engine comes in. What am I going to map different threats to? How am I going to process, the myriad of data that's coming down right now to my SIM, maybe down to a UEBA, process that in much more real time. Obviously, I've got to throw away probably 98% of the data that I see, right? Because I don't care about Active Directory logs necessarily. I don't care about firewall logs necessarily, but I do care about a SQL injection or a cross-site scripting request or a change in relationship model or a new IP threat vector. Then let's also build those, we have to build those relationships. We need to build those relationships dynamically in real time that's based off the behavioral patterns. Finally, moving to kind of the new world of what session management looks like across cloud. And what I mean by this is, if again, kind of going back to LDAP, right? It wasn't made to work across 2, 3, 4, 5 different clouds, right? I can't host in Alibaba and in Amazon and Azure. The replication, the data structure, et cetera, just doesn't lend itself well to that. So let's use cloud-native technologies to protect cloud-native services. And then use an abstraction layer to actually query the data stores underneath. So, let's offload LDAP, let's offload SQL, let's offload your API calls, let's offload NoSQL from the actual identities or the identity grid itself, and then let's just build relationships with pointers that go out to that data and retrieve it if and when you need it, or better yet, let's have that data publish itself onto a service bus that's extendable worldwide. So if you think about what Uber's doing, Uber's using Kafka right at the center of what they do. They publish about 2 trillion events a day onto that bus. That bus is replicated across all their hosted clouds, and they can pub-sub from that bus, or publish and subscribe to the data on that bus to upgrade changes from their APIs, changes from their microservices, and changes from their data sets. Finally, on the far right-hand side, we see these distributed policy decision policy enforcement points. And you'll notice they're all colored with kind of a blue background. And that blue background is because each one has to have their own specific application perimeter, right? We've heard it called a micro gateway, called a micro perimeter, et cetera. And that's actually offloading all of the identity functionality from the underlying business workload. So when you think about how it's being deployed in Istio or how it's being deployed in Kubernetes or Docker or Mesos, right? We don't want our microservices, our business function services, to have to know about complex identity logic, right? I want it to be as easy as possible so I can adapt my business functions as quickly as possible. And then looking at plugins into things like Apogee and existing Edge API gateways and serverless functions. That's why the AWS API gateway logo is up there. Being able to plug into those, because as you distribute your functions, as you distribute your workloads, as you distribute your services across cloud, you've got to be able to maintain that same level of authorization that's being present and defined over in your policy management and carry that through. And that's why we call it, the idealism of unified authorization, right? How can I bring network level micro-segmentation into the authorization engine, right? So then I'm replacing my firewall in this instance. I'm saying, can service A talk to service B, regardless of what cloud it's in? How can I perform OAuth scopes the same way, or OAuth scope evaluation the same way regardless of where I'm performing it, right? Doesn't matter what's an API gateway, a microservice itself, or a legacy app. How can I bring RBAC and mid-grained entitlements directly into it? In real time, passing it in a job or something of that nature as it gets carried down to these correlated applications. And then marry that to permissions consent. I mean, it's an absurdly complex problem. And then maintain a risk value, right? And that maintain a real-time risk value. And so the goal here is to allow our data security vendors, to allow our identity vendors to bring all of this stuff to bear, to publish maybe in the header or in the actual transaction itself, down to be intercepted by the risk engine or by the policy decision and policy enforcement points, how that risk has changed, and then adapt what's happening in real time to either mitigate it or process the transaction. So we think about like DevSecOps, right? So we're following, in this case, the plan, build, run model, right? So from a CISO perspective, I've got all my regulations, my risk acceptability, my permission consent policies, corporate policies, right? And I'm moving all of those into my CSO's plan. And then from a developer model, I've got kind of the same thing. You'll notice this is very similar to a CI/CD pipeline on the developer side. So I'm writing code, I'm committing code, I'm analyzing that code, and then finally I'm releasing it when I feel it's good enough. And then in the end, there's actually this runtime execution, right? Where I'm bringing in permission consent, I'm bringing authentication authorization, I'm publishing out those workload API policies to be consumed by my distributed decision points, and I'm doing service authentication authorization. So trusting each and every workload has its own identity, so then I need to attestate that identity, I need to authenticate, I need to authorize that identity as my transaction goes from workload A to workload B. And finally, kind of marrying that all together in monitoring. So let's give a unified monitoring to everything that's happening underneath. So what does that look like from a true CI/CD pipeline perspective? It looks like this, right, where I've got all the GRC planning, et cetera, happening at the top, pushing down permission consent policies into the application level authorization. I've got build, test, analyze on the bottom. I'm testing out those fine-grained entitlements, coarse-grained entitlements as part of my build process. Then I'm authenticating, authorizing developers as they go to publish code to ensure that they're indeed who they say they are, creating a signature of that code so I can later perform an attestation of that workload, that workload is indeed who it says it is. I'm publishing the API specs so I can actually do inspections on distributed workloads at that application-specific perimeter to ensure that I'm meeting it all, and then I'm monitoring it all in the end. Last thing that we really wanted to talk about is, what does identity orchestration look like? In this case, how can I use my my existing IDPs or OIDC, combine that with identity microservices to talk to my SaaS apps, giving every user, every device, every app its own unique identity. Here, I've listed just a few different ways that actually the authentication happens for those. Bridging that into a unified authorization model, which you've all kind of seen and wrapped. Marrying that to my DevSecOps policy, where I'm actually using my CSO to generate policies for everybody. I'm inheriting them across my BU and across my developers. So my developers can just build the apps and not worry about adherence to corporate regulations. And then using all of that, obviously, to secure the data. Creating the end-to-end audit. Like, is everybody here familiar with NYDFS? New York Department of Financial Services. It was the first regulation to say you have to be able to recreate a transaction from authentication all the way down to data store query if you're doing business in excess of $1 million in New York State. So you have to be able to have a tamper-proof audit of everything that occurred to generate that transaction. So what are some action items, because I'm running low on time? 1, create identities for every entity. 2, add intelligence. So remove the silos in security. For too long we've been focused on data security, network security, identity management. Add a single point for policy management and a robust policy management. Excuse me. Add a robust policy management definitions. Add enforcements at the workload level that are agnostic of the underlying language that you're using. Add DevOps integrations. If we don't engage our developers, we're never going to get ahead of the curve. Add orchestration. That orchestration can do everything from inserting discrete business process in the middle of your identity transactions or mitigate those risks in real time during the processing of transactions. And utilize risk as a dominant validator. And I want to be very careful when I say this, but each of those is such a large task. They're a rethink of identity management in many ways. But all combined together, it's almost a full reboot, in terms of how we've been thinking about it right now. So what are some of the benefits, from a summary perspective? 1, zero trust networks just become a thing, right? Hey, it's done. Everything's authenticating, authorizing each other. Everybody recognizes what it is. Identity begins at the local host. Authentication authorization happens everywhere, not just at the web access management layer or at the API gateway layer. Bringing in end-to-end security, regardless of application architecture. We've got to support, first of all, I think personally, we need to get in front of the developers first and then backport it to legacy apps. Because if we continue to let them run free, we're never going to be able to get ahead of the curve. And then build unified dynamic authorization. So one location for everything in an enterprise or across multi-clouds. And obviously, continuing that dynamic risk that's adaptive for end-to-end transactions. Any questions? I know it could have been 2 hours, but if there's anything burning on someone's tongue, you can just say you're wrong and walk out. That's okay too. It's that or I tap dance. Thank you, everyone. I appreciate you coming.